Good afternoon, esteemed speakers. Good afternoon, members and friends from the industry. Welcome to the interactive session on functional safety standard for safe machines, being organized by German Engineering Federation VDMA, along with our esteemed partner Deutsche Gesellschaft für internationale Zusammenarbeit GIZ. I welcome our speakers of the day, Mr. Wegner, Ms. Sawant, Ms. Moser, Mr. Desai, Mr. Gupta, and Mr. Kanchan. Welcome all. Friends, functional safety has always existed. However, with more human-machine interactions and the implementation of autonomous technology into machinery on our factory floors and cars, it has morphed into a specialized technical field and engineering discipline. The concept of functional safety applies to everyday life and every industry. It is more fundamental for safety-related systems. The oil and gas industry, nuclear plants, manufacturing sector, transportation and automotive, medical devices, all rely heavily on the concepts of functional safety to ensure the work environment is a place free of hazards. Functional safety and related risk management system requirements are increasingly in demand, especially post-COVID. Friends, the German Engineering Federation VDMA is an association of the German machinery and plant manufacturers with more than 3,250 members and over 1 million employees. It is the largest industrial association not only in Germany but in the whole of Europe. We are a 127 years old organization. We cater to 38 specialized sectors under mechanical engineering. Our members produce machinery worth euro 232 billion and export 78% of it. Having our head office in Frankfurt, we are also present in Brazil, Russia, India, China, Belgium, and Japan. Next slide, please. Over the years, we have built a member base of 3,250 companies. We have been receiving visitors of 45,000 visitors across the year, every year. We are organizing events, 1,500 events every year, and we have 600 dedicated employees. Next slide, please. In India, our managing director, Mr. Rajesh Nath, heads the organization in India. In West, our general manager and regional head, Ms. Jamie John, is there. And in the East, Mr. Sandeep Roy is the regional head. In the North, Mr. Rejoice Sengupta is the regional manager. And in the South, Mr. Manohar is the regional head. Next slide, please. Through this seminar, we would like to throw light on the importance of functional safety standards for an organization. We will also highlight the role of BIS in standard formulation and overview on machinery safety scenario in India. Also the role of GIZ on standards and regulations for safe machines. We will also talk about the importance of risk assessment and automation solution for machinery safety. I now request my colleague, Mr. Rejoice Sengupta, to take you through the program of the session, introduce the speakers, and take the session forward. Thank you.
Thank you, Ajmal, and good afternoon to all the speakers and panelists for today's session. So we have a very eminent set of panelists today. We have Mr. Wegner, who's VDMA in Frankfurt, who's been taking care of machine and electrical safety. We will then have the speaker as Ms. Maitri. She's from Siemens, and she's leading that product management team, and she will be speaking on the automation for solution for safe machines. Then we have the presentation from GIZ. Mr. Alok Kesri was supposed to join, but due to some engagement here, now one of our colleague, Vera Moser, will be taking up, and she will be throwing light on the Indo-German cooperation on standards and regulation for safe machines. We welcome you, ma'am. We have functional safety standards for safe machines, a perspective for safety solution. This will be taken up by Mr. Sameer Desai, who heads the product management SEC India Private Limited. Then we were expecting Mr. Rajneesh Khosla, who's quite known to all of you. But again, due to some meeting, he couldn't make it, and his colleague, Mr. Chandan Kumar, will be overviewing on the role of BIS in standard formulation and overview of machinery safety in India. And then we have a short presentation by Mr. Sameer Kanchan, and he's from the SafeTens, and he will be speaking on why risk management. After this 6 presentations are over, then we have a question answer session. So I would request that to all the speakers that since paucity of time, we'll stick the presentation to roughly around 15 minutes. So the first presentation we'll have from Mr. Wegner, Mr. Hermann Wegner from VDMA Frankfurt. Next slide, please. Now a short introduction of Mr. Hermann. Currently, he's the manager for machine and electrical safety in non-European countries. Having done his graduation in mechanical engineering, he has a total experience of 17 years from 1997 to 2014 in different organizations of repute in Germany. He joined VDMA in 2014, and here I take this opportunity to welcome Mr. Hermann Wegner for his presentation, and his presentation will be on the functional safety standards for safe machines. Mr. Hermann, next.
Excuse me, is it my turn?
Yes, sir.
Yes, okay. I'm afraid it seems that I've a little bit lost the audio. Okay. We've already seen this slide. I think we can skip it. Next slide, please. Okay. The topic of functional safety is not only a topic of technical standards, it's also a topic of several combined situations. For example, a safe workplace is the target everybody wants to join. But to have a safe workplace, you also need reliable processes in mechanical and in standards and in standard operations, and also contribute to this safe workplace and healthy equipment, because an unsafe machine will always cause accidents. Only a safe machine will prevent any kind of accidents. And to reach this target, it is necessary that all these, not only these three elements work completely together, but several others too. Next slide, please. Yes. Here we see the basics that are needed for a functionally product safety plan. First of all, we need a public law. In Europe, we have this public law separated in two topics. One is product regulations, and the second one is occupational safety and health regulations. Let me start with these product regulations. They are directed to the manufacturer of a machine, and the manufacturer. Sorry, back to the slide before, please. Thank you. Here it is important that the manufacturer identifies official regulations, public law, that fit to the product he's manufacturing. In Europe, in this case for machinery, there's of course machinery directive applicable. Sometimes it's a radio equipment directive, RED, electromagnetic capability, restriction on certain hazardous substances, RoHS, and waste of electrical and electronic equipment, WEEE. These technical regulations have to mention at least. Probably there will be some more, for example, pressure equipment, or for off-road mobile machinery. And this regulation makes sure that the manufacturer will only put a reliable and a safe product onto the market. That is the idea of the legislative corporations. The second side is the employer, the company that will work with these products, because a safe product itself is not really safe in the working process. And at this situation, you need also to perform something like a risk analysis on the workplace, and you have to keep the safety of the machinery and the toolings up to date. That means you have always to maintenance the machinery and the toolings, because only with maintenance you can keep a high standard of functional safety and processing safety. Next slide, please. For the product safety, especially in Europe, you have several documents. The first of them is Machinery Directive. It's in Annex 1. It describes a lot of mechanical risks, electrical risks, electromagnetic capabilities, and so on. And all these risks that are described in this Annex 1 have to be mentioned to the machine, and will have to be processed in a risk analysis where the manufacturer has to look at the machine itself, at the risks that may be combined with the machine, and to decide if these risks are acceptable or if they are not acceptable. These risks in this Annex 1, they are very common. They are not so specified, and it's not so specified what risk is acceptable and what is not acceptable. But to decide this, there exist some technical norms and technical standards like ISO 12100, safety of machinery, general principles for design, risk assessment, and risk reduction. And this risk assessment and risk reduction, that is the main task that has to be performed for a safe machine, because in this process, the manufacturer looks at his product, has to decide if there is a potential risk at this place or with the machine, and has to decide if that risk is acceptable. If it is acceptable, then it's okay. But if it's not acceptable, then there have to be taken some measurements to reduce these risks. These measurements are preferred in design changes. If the design change is not usable or not useful, then it is possible to take, for example, some technical preventions, safety curtain, safeguardings, or something like this. And if safety appliances are no more applicable, then it is okay to take some organizational prevention systems. For example, to describe the residual risk, and to say, for example, to use some personal protective equipment like hand gloves, jackets, helmets, or something like this. This ISO 12100 is also a very general technical standard, and for the typical machineries, there are a lot of they are so-called Type C standards. They are specific for one type of machinery, and in these Type C standards, this typical machinery is very detailed described in the risks and in common accepted methods to prevent these risks. These standards, also 12100, are so-called harmonized standards under Machinery Directive. And in Europe, a manufacturer using one of these harmonized standards can rely on the sorry, I've lost the right wording. For that the machine will be according to a machinery directive, and that you can put it on the market. But it's not done with obeying these technical standards. Manufacturer has also to obey some other points. For this machinery safety, there is, let me say, for the mechanical side, and it's often used from machinery manufacturers, this ISO standard 13849-1, safety of machinery, safety related parts of control systems, general principles for design. In this technical standard, it is described how a manufacturer can use these additional technical systems to achieve a safe machine. But it's not enough to apply the standard. You also have to use this second standard, -2, because it is very relevant to validate that the safety system manufacturer has decided to use is really useful and will be working correctly. For processing, there is another standard. It's called IEC 62061, safety of machinery, functional safety of safety-related electrical, electronic, and programmable electronic control systems. This standard is sometimes used from machinery manufacturers, but not so common. Because for machinery manufacturers, this ISO 13849 is more comfortable because it is more specific for the manufacturer of machines. Excuse me, there's something missing. This is IEC 61511, functional safety instrumented systems for the process industry sector, is also sometimes used for machinery manufacturers. But it, like the title says, it's more for a process industry, and it is a little bit different from the approach. The ISO 13849 is more from the mechanical side and from mechanical safety and supporting this mechanical safety. And the other two standards below, they are more for the functional and for the process safety of the electronics, for example, in this case. In the future, there will be one standard that will combine those 13849 and 62061 requirements, but I think this will take some years to get them together. Next slide, please. For the durable, safe machinery, it's not only useful to have a safe product on the market, but you have to maintain it. And this is the third one. Continuous maintenance for risk reduction is also necessary because the safety of a machinery will decrease by lifetime. This is described by this graphics. The lower one is inherent product safety by design. This is the safety that will be delivered from a manufacturer. And when the time goes by from left to the right side, this inherent product safety is decreasing. There are two factors. One is the information of these technical standards. When the machine is produced, they are state of the art, and the application of these standards is state of the art. But when the time goes by, there is some new information, new knowledge, and when you take this into regards, and this inherent product safety is slightly decreasing. And this is the blue. This is describes that blue triangle. After after some time the machine is in production, then there's probably a measurement like retrofit. And in this case, it is probably the ideal situation is to get the inherent product safety back to the original situation. Sometimes it will not be possible like this, and with further production, this safety of the machinery will still decrease again. And this retrofit may be possible 1 time, 2 times, 3 times, 4 times. But one day there will be a situation where this retrofit will no more be useful, because it will be too expensive to get the machine back into a real safe standard situation. Then it's time to scrap the machine and to buy a new one, for example. Next slide, please. For questions according to this technical and mechanical safety, I have my colleagues here, the contacts from them, and yeah, I have also my contact. If you have some questions in the future, please email me. Oh, unfortunately, this is a little bit. The email addresses are shifted, unfortunately. Sorry for this. Next slide, please. Thank you for your attention. And if you have questions, please ask them written. Thank you.
Thank you, Mr. Wegner. Now I would request the next speaker, Ms. Maitri Sawant. Now she's currently heading the product management digital industries for factory automation Siemens. She's placed in Mumbai. A little background of she's now graduated in electronics and telecommunication engineering from Pune. She has worked in the field for factory automation industry for a decade and has an experience in various domains within the automation industry. Handled the responsibility of tailoring and promoting automation solutions in solar, machine automation, water and wastewater, pharma, machineries, etc. She's currently heading the product management team. We welcome you, ma'am, for your presentation. Next.
Thank you. Yes, so very good afternoon to all of you. Safety machine. So safety of the machine or of the human working around the machine, and also of the environment in which the machine is working, has become an utmost priority for any manufacturers. So why is it so important, and how can we make our machines safe? So we will see it in today's session. So next slide, please. So let us see it with the help of an example. So let us understand this example as a cutting machine. So it's a metal cutting machine. So there's a clamp to hold the metal, the rotating cutting disc to cut the metal. And since this is an open cutting machine, it is evident that it is a very unsafe operation. To avoid any unfortunate incident and the relevant human or reputational or even monetary losses, implementation of safety becomes utmost important. Now, how do we make this machine a safe machine? Next slide, please. So there are 3 phases for making a machine a safe machine. So first, assess the risk of the machine. So understand the operation of the machine. All types of operation should be taken into consideration, may it be a manual operation or an automatic operation. Risks should be identified, and then there's a stage wherein you can have identify the methods by which you are going to reduce these risks. And ultimately, whether your methods implemented are really capable of reducing the risk to an acceptable limit, this has to be certified and validated. So these are the 3 steps. And going back to the example now, can we have the next slide, please? So going back to the example now, let us see the risks in this machine. So we see that this is a very open machine, and the cutting blade, it captures our eyes, and this is something very dangerous. The metal piece is also going through clamps, so there's a possibility that the hands of the operator can get crushed in this clamps. The operator can lose his arms as well because of this open cutting disc. And such cutting machines also emit a lot of dust on account of cutting, which might affect the environment and the people working in that environment. So these risks are usually categorized into certain levels of risk, so that necessary actions can be taken to reduce them. And these levels are categorized based on the ISO and IEC standards. So we have SIL 1 up to SIL 3 level, and we have PLA up to PLE level. So considering this example, I can see we have a very severe risk. So let us categorize it. Can we have the next slide, please? So here we see that if the cutting disc injures the operator, he has a chances of losing his arm. So this is an irreversible injury, and it's a very high risk. And how frequently it is supposed to happen, it is expected to happen. So since it is an open machine and the operator is working on it in shifts, maybe 8 hours, so it is very likely that he might get injured. So this risk is categorized at a very high level. So now let us see what are the steps that we can take to reduce this. Next slide, please. So like Mr. Wagner has also explained in his slide, so there are steps that we have to take to reduce risk. So first you try whether the change in design would help reduce risk. So if the risk is still not mitigated enough, then you have to look into the technical measures implemented into the machine, try changing the measures or implementing safety into the technical measures. And here usually the risk is reduced to a good level, but still if there is any residual risk, then there is possibility that you can use information or notices to the users on what instructions to be followed while operating the machine. So let's implement back on our example. Next slide, please. So here now, since it was very open machine, we have given it an enclosure, and this enclosure will avoid exposure of the operator directly to the arm that was cutting the metal. So this will reduce the risk to a good extent. This is what I feel, but let us analyze it. And next, we cannot completely close the machine because there has to be some access given to the operator to access the machine when required. So there's a sliding door here. Now let us see the risk chart again. Next slide, please. So as the risk chart is So as the risk chart is showing that though we have given an enclosure, the risk is reduced, but only the probability is reduced because the frequency of the operator getting exposed to the harm components of the machine is getting reduced. But the severity still exists because if he uses the sliding door and accesses the machine, there are chances that he still can lose his arm. So the severity is not yet mitigated. That's why we have to go to the next stage, and that is technical assessment. Next slide, please. So here, let us go to the technical assessment on the same machine and see how we can handle it. Next slide. So talking on the technical part now, what we are trying to do is we are going to detect the position of the protective door. So understanding the position of the door, if in case we get a feedback that the door is open, immediately a command has to be passed on to the motor to stop. So the machine should stop. This would avoid any harm caused to the operator while he's working on the machine. Additionally, we also give an emergency stop to the operator so that if he feels it is unsafe situation, he can himself stop the machine. So next slide, please. So here we saw that since the chances of the operator getting injured because of the disk is reduced to a good extent. And since he's going to open the door and the machine is going to stop, so maybe at the most he will have a cut or something like that. So this is okay, we are in the green zone now, good to go. So this is how we mitigate the risk of an unsafe machine. Next slide, please. So what we did here to mitigate the risk was that we detected the position of the safety door. We evaluated what has to be done, whether this is an unsafe condition first and what has to be done, and the necessary action was taken by giving a command to the motor to stop. So the cutting disc was also stopped immediately. So this is where the safety system fits in. And the safety system works in 3 levels: detect, evaluate, and react. Next slide, please. So evaluation is the stage in the safety solution where the automation plays a big role. So evaluation, the PLC as well as the IOs play a major role there. Now this PLC and IOs I am talking about is a safety PLC and a safety IO. So the safety CPU and safety IOs, they are designed with an inbuilt testing circuitry. So it comprises of a dual channel processors in order to confirm the signals received. And it also follows a coded processing technique, which creates a diverse logic. And this logic is created on the received signals, which ensures that the detection of fault is surely confirmed. Any discrepancy, if detected, the signals are sent on priority to bring the machine to a safe shutdown. Additionally, these IOs, which are used, the IO modules, they are also designed to continuously monitor for errors like short circuit or wire break, etc. So this continuous monitoring can also help to early detection of problems and bringing the machine to a safe shutdown at the right time. Next slide, please. Uh, Next slide. Thank you. So these modules as well as the safety PLC is continuously evaluating, and there is some thing called as passivation and depassivation which it follows. So in a continuous diagnostics of the sensors and the actuators by the fail-safe module, it detects whether some error is occurred, and if some error is occurred, then a module is gone into a passivation state. So it is de-energized. The DOs become de-energized. So there are possibilities of module passivation and as well as the channel passivation. Now, in case the error is eliminated, a normal PLC would just start when the error is eliminated. But for a fail-safe condition, though the error is eliminated, the depassivation is still not done. In this case, again, an acknowledgement is expected, and on the acknowledgement only the depassivation is done and the DOs are re-energized. Next slide, please. So this safety IOs and safety controllers, what are the possible variety available in the market today? So it is not that fail-safe controller for fail-safe application, you have to go for a very high level of controller. So there are fail-safe controllers available right from basic automation level up to advanced controllers. There are also fail-safe controllers available in distributed architecture. In case you want to install a soft controller or soft PLC on your PC, that is also possible with soft controllers available in fail-safe variant. And in case you want to implement a high-level language program along with a PLC language program on the same platform, so that is done by an open controller, which are also available in fail-safe versions. Now, these we talked about all mounted in IP20 type of installation, but there are controllers supporting fail-safe operation in IP65 and 67 type of installation as well. Moving on to the variety of IOs that you can choose from. So there are centralized IOs, the standard IOs and the fail-safe IOs can be mounted together on a single controller. Then there are distributed IOs for a decentralized architecture. There are fail-safe distributed IOs as well. And in case you want to mount the IOs directly on the machine, that is possible. We have the fail-safe IOs on supporting IP65 and 67 installation as well, and mounted on the machine and supporting all the vibrations necessary for that. So all this is available in the market, not only to the control and IO level, but also onto the HMI level. So we have HMIs having an inbuilt emergency stop, and these HMIs and even the distributed IOs, they speak to the controller on Profinet, but this Profinet also supporting fail-safe, and that is called as ProfiSafe. Talking about ProfiSafe, let us go next to fail-safe on communication. Thank you. So fail-safe communication with ProfiSafe. So what is ProfiSafe? It is safety. It is a safety profile of the Profinet protocol. So ProfiSafe is a profile on Profinet, and it allows standard as well as fail-safe data transmission on the same cable. So however, they are independent, so they form a black channel. It is created for timely transfer of safe data. Then these frames include the integrity check, so integrity data check, so that is the CRC data. It also includes the timing information. Time monitoring is done continuously, and that information is embedded here. And it also has accurate identification of senders and receivers also embedded. So this means that ProfiSafe ensures right data at right time and at right place. So you can see that it is not only limited to a wired communication. ProfiSafe also supports Profinet wireless, so that there is a profile which also supports wireless safety on with ProfiSafe. So in case you want to check whether a device is supporting ProfiSafe, you have to check for the symbol here on the right hand corner. And this yellow with a red dot indicates that it is complying to ProfiSafe. So it can be easily used in a safety system that you're going to use. Moving next slide, please. So moving next to the engineering software which we will use to program these automation systems. So what is important here, that now we understood that there's so much of task of evaluation that the PLC and the IOs are expected to do. But there has to be some library available, so that it is ensured that the right programming is followed while programming the safety application. So for that, we also have a safety library, and the engineering softwares that you choose for the automation or for automating your safety solution should support this library. It's certified for safety applications. Furthermore, the engineering software should also support testing. So once the engineering is done, it should also allow you to test without connecting a hardware, in order to be sure that it is working good enough or as per expectation. And then you need to have a common database. It would be very good to have a common database, because safety programming is a little complicated. So if in case you do any changes somewhere, it might affect the programming wherever it is connected. It might affect in the program. So to avoid this, a common database would also help change management. So this is about how you select a engineering software for your safety solution. Can we go to the next slide, please? Okay, so now using the fail-safe PLC, using the fail-safe IOs, the engineering platform, and all the communication safety that we spoke about, this is the architecture that is usually used. So we have a standard system which people use for standard application. So in an application, if there are two parts, one is requiring a fail-safe automation, and one is requiring a standard automation. So to optimize their offering, they tend to use a standard PLC and a standard system for the standard part, and a fail-safe system totally isolated for a fail-safe part of the same application. What happens here is, okay, this is good, but this is very traditional now. And what happens here is there's a lot of wiring, there's a lot of engineering efforts, and there are so many interlocks, so to manage it becomes a little critical. So there is also a new trend which has evolved and which we as Siemens are continuously promoting, and that is integrated safety. So we see it on the next slide. Next slide, please. Yeah, thank you. So by integrated safety, we mean that you integrate the standard as well as fail-safe application together in the same system. So here you are using one controller which supports standard IO modules as well as fail-safe IO modules. If you have a distributed IO system, then same stands for distributed system as well. So you can have a combination of standard as well as fail-safe. But since it is communicating to the standard PLC on Profinet, so ProfiSafe is something which is necessary for safety over communication. Then right from the sensors up to the actuators, we believe in throughout all fail-safe solution, one window solution, which is available even with Siemens. And we have devices which support ProfiSafe right from the HMI level, the engineering software, as well as all the sensors and the drives. So all in all, this is an integrated safety that we are offering. One thing we should be sure that we are now in terms of industry 4.0, and we should also see that the solution we are using should also be scalable enough for the new trends and technologies that are coming up. So the safety solution that you're using here, an integrated safety solution, can also be scaled to cloud and edge functionalities in future. In fact, you can also have a digital twin with the help of the simulation softwares for the entire machine. And the benefit is you can train the operators on that machine, not only how to operate the machine, but also in case of failures, what should be their reaction. So if they are trained, then they are safe. So this is how, with a total automated solution, I am sure you will have a very safe machine. And not only that, you'll also have a very high productivity. Thank you.
Thank you, Madam Sawant, for your exciting presentation and thereby giving some overview on the solution, automation solution for the automation safety. Now we have the next speaker, Madam Vera Moser. She's from Germany. She's from GIZ, Delhi unit, but currently she's from Germany. Now, a small brief, she joined GIZ in 2018, and she holds a master degree in international affairs and global economy and strategy. So she has worked in the areas of technical regulations, conformity assessment, and market surveillance. Over to you, Vera Moser.
Thank you very much, Richa, and good afternoon, everyone. Next slide, please. I'm presenting today on behalf of my colleague Alok Kesari on the Indo-German Cooperation on Machinery Safety, and I would like to start with the question why machinery safety matters. There are several thousand occupational accidents taking place every year, and safe machines, machines that conform to relevant safety requirements, protect workers and the environment, but machines that are safe and of good quality also contribute to efficient production processes, for example, by reducing downtime. And of course, machinery safety is also an important topic because of new opportunities that have opened up in the manufacturing sector, for example, through the Make in India initiative. Next slide, please. The Indo-German Working Group on Quality Infrastructure provides a forum for both countries to discuss the significance of machinery safety and also to understand each other's approaches to machinery safety. It was established in 2013 by the Indian Ministry of Consumer Affairs, Food and Public Distribution and the German Federal Ministry for Economic Affairs and Energy. And the working group brings together representatives from ministries and government institutions, standards and accreditation bodies, industry associations and companies, as well as technical and scientific institutions. and provides a forum for political and technical dialogue between all of these key stakeholders. Next, please. The project in India is part of the Global Project Quality Infrastructure of the German Federal Ministry for Economic Affairs and Energy, BMWI. And the Global Project Quality Infrastructure has the aim to reduce technical barriers to trade, to enhance protection of consumers and product safety, and also the safety of industrial production sites. And BMWI has commissioned GIZ to support the implementation of the Global Project Quality Infrastructure in India, but also in other countries that you can see on this map, namely Brazil, Mexico, China, and Indonesia. For everyone interested in more information on this project, please visit our website, which is indicated on this slide, gpqi.org. Next slide, please. Here you can see a picture of this year's annual working group meeting, which took place in January in Delhi. As part of these annual meetings of the working group, each year a work plan is mutually agreed and signed between both sides. And as you can see on the next slide, the topics of cooperation which are agreed in the work plan are clustered according to the elements of quality infrastructure. So that is standardization, accreditation and conformity assessment, and product safety and market surveillance. And the topics falling under these categories are quite diverse. For the work plan 2020, which you can see here, they range from mobility, energy, to medical devices, chemicals, and of course also machinery safety. Next slide, please. Now diving a bit more into the topic of machinery safety, this slide provides an overview of the key pillars for ensuring product safety in the EU. Harmonized legislation in the EU is only established by essential requirements, and detailed technical specifications are laid down in so-called harmonized standards. Applying these harmonized standards is voluntary and not mandatory. It can be beneficial for economic operators as it provides them with the so-called presumption of conformity, but they can also have the option to create their own technical solutions that may go even beyond the harmonized standards, which overall is enabling innovation in the system. Before placing a product on the market, the manufacturer has to carry out conformity assessment to demonstrate that the product complies with all requirements. And the CE marking, which is then affixed by the manufacturer, is basically the visible self-explanation that a product is conforming to all applicable legal requirements and that a conformity assessment procedure has successfully been carried out. Now, since overall a lot of responsibility in this system is given to the manufacturers, market surveillance is also a very important element because it serves sort of as the public control element in the system. And I think this overview shows that product safety in the EU in general is ensured by a close interplay between different elements, technical regulation, conformity assessment, and market surveillance. And this is, of course, also the case for machinery safety. And all of these elements, I think, are also important to be considered when discussing machinery safety in the Indian context, although they could, of course, be designed differently and according to the Indian context. Next slide, please. A publication called Making Safe Machines a Standard in India was prepared within the framework of the Indo-German Working Group in collaboration with VDMA in 2018. And it provides an overview of the EU Machinery Directive, outlines the current regulatory landscape for machinery in India, and also includes and identifies challenges faced by the industry. And it also includes recommendations on the way forward for Indo-German cooperation on machinery safety. And this publication can be downloaded for free on our website, gpqi.org. So please feel free to visit there. Next slide, please. Now, based on the conclusions from the study, the need of the hour for machinery safety in the Indian context are regulations for machinery safety that will enhance the competitiveness of the industry and promote safe working environment, a roadmap for implementing standards and conformity assessment procedures, as well as creating awareness about machinery safety in general and promoting and building a culture of safety through the adoption of international good practices. Next, please. And based on these conclusions, current proposals for the way forward for Indo-German cooperation in the field of machinery safety are to provide support to OEMs and the user industry on how to meet applicable standards and regulations, then also sharing of implementation experience of the machinery directive from Germany, and also to share best practices on how to develop a market surveillance system for machines. Next, please. We would highly encourage you to get involved in the working group and to get in contact with us in case you have specific questions, and all the details are provided on this slide. Thank you very much.
Thank you, Vera. Now we have Mr. Samit Desai from ZIC India Private Limited. He's the head of the product management. Around 25 years of experience in the field of industrial automation and sensor, having worked in a lot of German multinational companies. He has worked with various industries, customers in the field of factory automation, logistic automation, and process automation. And he has also in-depth knowledge of industry requirement when it comes to implement of sensors and automation solutions. So we welcome you for your next presentation, and would request you to keep to the time because we have a lot of participants who will be throwing questions. So I will request you to keep within the time limit, sir. Thank you.
Yeah. Good afternoon and a warm welcome from myself and ZIC Sensor Intelligence family. Can we go to the next slide? Now everyone is talking about functional safety standards in India. So everybody who is attending this seminar must be wondering why it is so become a buzzword today. The reason is the safety standards. If you look across the world, next, move ahead. Yeah. So there are a lot of countries which are having the safety standards which has been implemented. For example, there is a Europe, there is a CE and EN standards. In US, there is a ANSI UL standard. In Brazil, there is a NBR standard. These are all the standards basically used for the safe machines. And in India, you can see there is nothing here, but actually there are a lot of safety standards which are already there. But right now, these are all voluntary. So there is no mandatory rule that for so and so machines, there has to be a certain standards which has to be mandated. Of course, government is working on this and some development is going on, which we will get to know in our next presentation from BIS. And as mentioned by Ms. Farah, that there is a German group also working closely with Indian government to see how we can design and implement safety standards in India. Now, as a safety solution supplier, I am going to provide the perspective how we look at the safety standards. ZIC Germany was very deeply involved when machinery directive standards was developed, and we are also closely associated with BIS and GIZ when the safety standards discussions are ongoing. So despite there are various standards, there are two mother bodies, the mother standards, which remains IEC and ISO. So most of the standards are derived from them, and most of the countries have made some minor adjustments to suit to the local requirements. Go to the next, please. Coming from German company and with association with all this GIZ and this working group, it makes sense to have a look at what has been done at the European Union. They have implemented these safety standards. I will not go into much detail, but for us, it is imperative to understand that there are two parts of this. One is for manufacturer, one is for the end user. Next. So if you look at this machinery directive 2006/42/EC, which is very famous machinery directive, which is applicable for manufacturer and for the end user. Next, there's a work equipment 2009/104/EC. So these are the two directives which is guiding both manufacturers and user. Go to the next slide. Now, what does this machinery directive calls for? It is talking about the machinery directives for the manufacturers. So manufacturers of machines, integrators, for example, someone is manufacturing a robot, somebody is taking this robot and implementing robot cells, so he becomes the integrator. There are distributors of machines who are just buying and selling, and there are people who are providing safety components like safety sensors or safety PLCs. So those all people are covered by this machinery directive, and there are certain obligations on them. These obligations are risk assessment. So they are supposed to assess the risk of a machine. They have to ensure that the machine has a safe design. They must eliminate, if not possible, then must minimize the risk, and then provide technical documentation, operating instructions before they put their machines with CE mark in the machines. Now, when it comes to the end user, the people who are going to use this machine, again, there are some obligations. They have to ensure the safety of machines. They also need to eliminate or minimize the risk. And the most important part is there has to be inspection or testing by an expert. So it is not, your work is not ended once you buy a very safe machine. You have to periodically inspect it, testing by an expert, and ensure that this machine is working as it should have been. Also, there are some ergonomics and occupational health hazards which you have to take care, and provide training to your workforce about the work equipment and the risk involved with the work equipment. Now, I hope most of these things will also get implemented in India, more or less similar manner with some minor changes. So it becomes imperative for people, either you are a manufacturer or you are a user or a safety component provider, to have in-depth knowledge of these safety standards and to see that how this can be implemented when it becomes mandatory in India. Let's go to the next step. Next slide. Now, as a manufacturer, you would always like to design according to the state of the art, and as an user, you would like to have the state of the art operations. But what happens? You just cannot put your machines just like that in the market. Next, please. So you have to do risk assessment. You have to reduce the risk if you are a manufacturer before you put your machine, before you sell your machine to the end users. And the end user also has to do the risk assessment. He has to maintain the machines, and after putting into service, the employer has to do regular inspections. So his work is not over. So there is a periodicity which has been given depending upon type of machines. At minimum, it is 2 years in Europe that you have to get these periodic inspections, safety inspections of your machines. And for the machinery manufacturer also, if he makes any substantial modifications in the design, he needs to revalidate the machines. So these are the basic aspects of the safety standards, though it looks a little bit scary that there will be a lot of standards and what is to be done. But if you follow this simple methodology, you can decide what is to be done, what is required to be done. Next, please. Now, if you look at the standards, there are different type of standards which talks about type A. Next, please, type B and type C. So if I give an analogy of a building, so let's say type A, which talks about the general requirements about risk assessment. So every building must have a foundation. The type B is generic, so it talks about safety aspects and safety devices. So let's say we talk about building. So it could be, what could be the material, the bricks, the wood, the structure, the pillars, something like this. And the type C is very, very specific. It could be to particular machines, like for example, robot cells or something like this. So this is how the different safety standards have been segregated. If you go to the next slides, again, I'm going to show you a lot of standards, but don't get scared by these standards. We can move ahead. Next. Just get the full slide on. Yeah. So you look here on the top, we are talking about very, very basic safety, which talks about either electrical safety, pneumatic safety, and how to have safe setup. Now, if you look on the left-hand side, on the red squares, I have shown that you can make a machine safe by using the guards. The guards could be fixed or it could be movable. In case if it is movable, you can use gates, flaps, barriers, and then you have to follow certain safety norms. Next, please. You can also use electro-sensitive protective equipment, yeah, or you can also use the pressure-sensitive protective equipments like safety mats or safety light curtains and safety scanners. So it is not that you are supposed to use everything, but you have to assess the safety risk assessment of the machines. Then you have to design safely and then decide which component to use and how to make your machines safe. So this is the chart generally we will follow, and then we decide which standards to go for. Go to next, please. So let's say you are an user, you are running a factory and you say, okay, I am going to put a lot of safety components. For example, in order to guard the access, I will put either safety barriers, safety interlock, electromechanical switches, or if I have to have the point of operations, if my operator is putting some job into the press machines, I will put safety light curtain. Or if you go next, maybe for area guarding, we can use safety light, safety scanner, and then you use a lot of safety devices and you wire this to the FlexiSoft safety PLC. Next, please. Next, one more. Yeah. So now the question is my machine safe if I use all safety components? Now everybody will think that, okay, I'm investing a lot of money on this, I'm buying a lot of safety devices, everything looks yellow, everything should be fine. But what could be the answer of this question? Is my machine safe? I would say, even if I use all safety components, the answer would be no. And this is where the safety standards comes into picture. For example, I will give a very simple example. If we are going to use, let's say, safety light curtain, then it makes sense to decide where you are going to put your light curtains in the machines. Where means which positions, where is the hazard, if it is a press machines, and if you put your safety machines too close to the hazardous movement, so by the time the safety light curtain is infringed, there are possibilities, I'm not saying it's, but it depends. There are possibilities that the safety mechanism works, but you are still in touch with the hazards. So this is where the safe design of a machine, the risk assessment and everything comes into picture. So it is not always about hardware, but also about the safety services. So when it is not sufficient that you buy safety component and you implement your safety, your machine becomes the safe machine. So if you go to next slides, SICK has very wonderful literature documentations available. We call it 6 steps to safe machine. There's a lot of information on how you can make your machine safe. This booklet can be downloaded from our website www.sic.com, and it can be used by anybody, whether you are a machinery supplier, machinery manufacturer, or an user. So it talks about local laws, regulations, and standards. This is the first thing, because it is going to change from country to country. Then it talks about risk assessment, and then we are talking about these 3 steps, which I talk in my next slides. And then comes the validation, and then placing it on the market and transferring the risk. Now, if you look at the 3-step method of reducing the risk, so can you move next, please? Yeah. So the task is, let's say, have a safe design. So either I would like to eliminate to the extent possible or minimize the risk. I will check whether it is possible. Next, please. And I say, yes, it is possible to make a safe design. I will check whether it is yes or no, and then say whether the risk is acceptable. The answer could be no. Then I go back to the redesigning the system. If the risk is acceptable, after redesigning, then I will put my machines with acceptable risk in the market. Now, the next step is, if it is not possible, that you cannot eliminate or minimize the risk, I need to safeguard. So I need to put some sort of safeguard. The safeguard could be safety fencing, it could be light curtain, it could be safety scanners, safety switches, anything. After implementing this, you again check, is there any residual risk? You ask these questions, and again you move ahead and say no, you can put your machines with acceptable risk. And then there are chances that in certain cases there are still some residual risk. So you try to eliminate, you try to minimize risk, you try to safeguard, but still the residual risk remains. And this is where the administrative measures come into picture, which is nothing but providing information to the users, to the operator, that there's a risk with these machines and you are supposed to operate in so and so manner only. And this is where the documentation part comes into picture. Go to the next, please. So what we are trying to do, we are trying to avoid the hazards. If avoiding hazards is not possible because the operator has to put the job into the press machines, then go next. Then we have to safeguard it. Next, please. And safeguard, after the safeguarding also, if there is a residual risk, we need to inform the people that this machine has a hazard, there is a unsafe behavior, unsafe movement is here, so you have to be a little bit careful while you are working in this area. Next, please. So if you look on the left hand side of the graph, on the top side, there is a lot of risk, yeah, and you can see the severity of harm and the probability of occurrence is very high. So this is where the safety metrics come into picture. And on the bottom side, left hand side, you can see there's a ferocious roaring lion, which is a significant hazard. Now I'm just trying to explain you with this symbology. Now if I implement safe design measures, I can maybe change the picture of lion to maybe a panther or leopard there. So little bit, I would say, less scary. And again, if I put some more protective equipment, yeah, if I put some electrostatic protective equipment, if I put some pressure, power and control mechanism, if I'm using robot, so it is like putting this leopard behind the fencing its cage. So I feel a little bit safer. And still, people who are not aware that there is a leopard behind this cage, you can always put this sign that there is a risk behind this and you have to be careful. You should not poke your finger inside, otherwise you might lose your finger. So this is how the safe designing of a machine works. This is at very, very broad level. The standards I try to explain. I will give you one example, which I hope can give an overview. Just go to the next slide, please. Yeah, just move ahead, please. Next. So what happens? That, as I mentioned, it is not only necessary that you buy safety components or safety hardware or you buy safe machines. There has to be a risk assessment which has to be done, and this is where the service part comes into picture. So all the users or these machinery manufacturers, they have to undergo this particular cycle, and we also offer such kind of expert services where we do the risk assessment of a machine. After assessing the risk, we can offer you the guidance on the consultancy on the safe design, how to use, which component to use. We will also do the commissioning check once the machine is installed. The initial inspection, the first inspection can be carried out, and there has to be a periodic inspection because every 2 years we have to check. It so happens that there are safety measures. When you buy the machines, after 2 years, a lot of maintenance, people change. So there might be some changes. So you need to check this periodic inspection. And most important part is during all these inspections and assessment, we are also going to check the stop time measurement. Now this is very, very important. We are using safety in order to avoid hazards. So if there is an unsafe movement, we would like to control this and we have to stop this. So by the time I put my hand inside the press machine and the safety light curtain is infringed and it is giving a command to the motor, the contactor is energized and motor is stopped and the mechanical plunger has come stop. So all this, it is going to take some time. So we should be very precise in calculating this, and this has to follow these safety guidelines. Otherwise, even if there are safety measures in place, safety devices in place, there are chances that there might have accident might happen. So all of you, please keep in mind, this is going to be the next phase of our professional life where we have to live with the safety hardware, not only with safety hardware, but also the safety services. If we take the next slides, I will give you one example of an automotive line where the robot is fixing the windshield of a car. Now, if you look at this first picture, everything looks open. Anybody can walk close to the robot. There is a workbench where the windshields are placed. An operator can come and put the windshield there. Now, if you go next, just click once. Yeah, so there are two hazards. Just go back. There are two hazards. One is with the workbench, which is moving, and one is with the robot. Now, if I follow the 6 steps of the safe machines, I will assess the risk, I will try to make it safe, the design, and then I will put the safeguards. So if you go to the next and final slide of my presentation, you can see that I have put fencing all across the robot. So nobody can approach the robot from any of this side. The robot movement is very, very risky. Anybody can get injury because of its movement. I also put, if you see on the fencing, there are 2 light curtains. One is horizontal and one is slightly vertical. So it is put in cascade mode. So if the workbench is moving, if somebody walks in those areas, then also we can control the movement of workbench. Either we can slow it down or we can stop it down, or we can, at that time, we can also stop the robot. So depending upon how the productivity is getting affected, how we would like to do your operations, these are the various mechanisms which can be employed. So it is not only buying and installing the hardware, whether it's a safety PLC or the safety light curtain, but we have to be very, very precise where it is mounted, why it is mounted there, what are the risks and what are the hazards. Now, again, you also need to periodically check after 2 years, maybe the fencing has been, somebody has removed the fencing or not, and this is where the periodic inspection comes into picture. So this is all from my end. I hope I am able to give you some insight on how you can make your machines safe. If there are any questions, we will be happy to take later on. Thank you.
Thank you, Mr. Desai, for an excellent presentation. I would also now request the participants and those who have logged in, if you have questions, start writing on the box which is on the right hand side. Now I take this opportunity to welcome Mr. Chandan Gupta, who's from the Bureau of Indian Standard. He's a senior scientist with the Mechanical Engineering Department, and he's a BTech from IIT Baddi, Himachal Pradesh. He has been associated with BIS from 2012 in the standard formulation activity. Mr. Chandan Gupta, please, the floor is yours.
Thank you so much, VDME India, for providing us the opportunity to interact with the different stakeholders, which are more or less related to the safety of machinery. Now, in the experts previous to me, they all talked about machinery safety, risk assessment, and one common thing. These were also a common thing. They talked about them in detail, but one thing they talked about is standards. So, in my presentation, I will talk about how standards are made, what standards we have made so far in the machinery safety, and how they are going to be used by the concerned ministries in their regulations. So, as you are aware that BIS is a national standard body of India, which has been empowered through BIS Act 2016. Earlier, it was known as ISI. In many products you may see in consumer products, ISI mark is there, just equivalent to CE marking. So, up to 1986, we were acting as a society, as a ISI, Indian Standard Institution. This was our previous name, but Government of India through BIS Act 1986 took over the asset and liabilities of ISI and named it as BAS, Bureau of Indian Standards. So these are the main activities of BAS, the core activities in which standard formulation, in which all Indian standards. In India, if you see, if you can call Indian standard, then it has to be published by Indian BIS, right? And it has to be notified in the official gazette of India. And other activities of BIS are product certification, laboratory testing and calibration, hallmarking, you may be aware. And in March 2021, it will be mandatory for every jeweler to get it registered with BIS if for hallmark jewelry, so that purity is pure 916 gold is available as they claim to every common consumer. Management system certification training, we are having a dedicated training institute at Noida. Consumer awareness and complaint handling with respect to any complaints to the ISI mark products. So this is the typical standardization space. If you see in the x-axis, these are the subjects. So you name any discipline. So BIS is making standards in that discipline, be it engineering, industry, commerce, science, education, transport, food. Everything is covered under the various division councils of BIS regarding standardization point of view. In y-axis, you will see the levels of standardization like international standards. So when I say international standard, only ISO and IEC are the international standard bodies whose standards are known as international standards. BIS is a founder member of IEC and ISO. Below that, regional level standard, like in European region, European standard is there. National standard, like in India, BIS is there. In any other country like China, SAC is there. In Germany, DIN is there. So every country is having their own national standard body. The standardization can happen at the previous one, please. Previous slide, please. Standardization can also happen at association level, company level, or individual level. And these in z-axis, these are the various aspects in which standards are made, be it a product specification, code of practice, test methods, sampling, nomenclature, etc., etc. So these are the aspects of standardization. And next slide, please. Next slide, please. This is the general structure of BIS, in which the top body is Bureau, which is chaired by our Honorable Minister of Consumer Affairs, which is our parent ministry. Under there is a Standard Advisory Committee, which there are many advisory committee in BIS, like Labs Advisory Committee, Certification Advisory Committee, uh, only all those major activities which I talked about earlier in my slide. So all the advisory committees are there, with whose prime function is to guide and to motivate the division council and technical committees to make standards in the given field. There are around 14 division councils in BIS which are making the standard in various respective disciplines, be it textile, be it electronics, be it electrical, mechanical, food. So like that, we are having 14 division councils in BIS, and in each division council, we are having various technical committees and subcommittees under and panels under these technical committees. BIS is itself is not making standard. However, I would say that BIS is a enabler and is providing a platform to all the stakeholders to come and make standards as proposed in the committee. Next slide, please. These are the various division councils, chemical, civil, electrical, and I am working in mechanical division councils, MEDC. Next slide, please. These are the various sectional committees in mechanical engineering division councils, and one of the committee is safety of machinery sectional committee, MED40. Likewise, we are having various sectional committee from refrigeration, from gas cylinders, which is very important committee from consumer point of view. We are having oil burning appliances, gas burning appliances, many more things. So these are the individual committees which are having specific scope and formulate Indian standards in the given field. Right. Next, please. This is the just the composition of the any sectional committee. Sectional committee is constituted by the division council, and whose members could be from manufacturer, consumer, government organization, technologists, testing laboratories, consultants, and other experts. And in our regulations, it has been mentioned that the interest of the manufacturer shall not exceed 33% of the total strength of the any committee. Next slide, please. This is the typical workflow, how standards are made in a given context. Not necessarily this is a fixed workflow, but it can be reduced or extended based on the complexity of the document and as per the decision of the committee. So to start with, any new work item is being proposed, so it shall be accompanied by initial draft. So it is circulated amongst the committee members, and if the committee is satisfied that the overall outlook and the structure of the standard draft is okay, then it can be processed for pre-draft and again circulated to the committee members for their comments. And one more thing I would like to highlight is that BIS do extensive stakeholder consultation before we finalize the any standard as an Indian standard. So when the pre-draft is completed by the committee level, so if the committee feels that draft is okay, and it can be released for public consultation. So as per our rules in BIS Act, the document has to be web hosted and circulated to our stakeholders for minimum 30 days. Any comments are received are again referred back to the committee, and the committee take the conscious decision whether to accept or to reject those comments and modify the document accordingly. And committee is the final authority to finalize the draft. So in the meeting, it is finalized. Then we do the processing of the document and formatting of the document as per IS 12, and automatically it has to be gazette notified. So no standard is come into force unless it is notified in the official Gazette of India, and it is finally adopted by the Division Council. And one more thing I would like to highlight, that Indian BIS is making voluntary standards. That means if somebody wants to take the license against the particular Indian standard, they can take. But if it is the only the government of India which can enforce the standard as a mandatory standard, that means it will be applicable to every manufacturer to manufacture, to store, and to sell. Then he has to comply to the standard and take the certification from the notified certifying agency. Next, please. Next, please. So if standard, if some typological errors are there, or and one more thing I would like to highlight, Indian standards or any international standard or the national standards, they are not rigid. That means we are open to amendments of progressive and positive changes in the standard, which are having positive impact on the quality of the product for making it more safer and user friendly. And generally we revise our standard after 5 amendments. Next, please. So as per our BIS Act, we have to review our standard. So what are the course of action? We can reform it as it is, or if certain changes are required, we issue an amendment, or if major changes are required, we take the standard for revision. And if it is the technology of the product is not being used and it is felt that it is absolutely obsolete, and with consultation of the stakeholders, we withdraw such standards. And a review, systematic review, has to be take place at least once in 5 years. Next, please. Next, please. As informed earlier, BIS has constituted Safety of Machinery Sectional Committee MBD40, and whose scope is standardization of the basic concepts and general principle of the mechanical safety of the manufacturing machinery, incorporating terminology, methodology, guards, safety devices within the framework of ISO, IEC Guide 51, safety aspects, guidelines for their inclusion in standards and in cooperation with other technical committees. So basically, this technical committee is National Mirror Committee of ISO TC 199. This is the National Mirror Committee of the same. This committee is taking care of Type A and Type B standards. Type C standards are being made in the different sectional committees which are having their area of expertise in the given context. I would like to add here that and this MBD40 is covering the mechanical aspect of the safety. Similarly, one of the other division of our BIS is electrotechnical division. So there is another committee, ETD 44, which is safety of machinery electrotechnical aspects. So they are dealing the electrical safety area. They're also dealing Type A and Type B standards in their field. Next slide, please. It is the National Mirror Committee of ISO TPC 199. We have in this committee 2 standards which has been published by ISO TC 199 has been adopted as Indian standard. This also includes ISO 12100, which is for safety of machinery, general principle for design, risk assessment, and risk reduction, which is the mother standard for any safety of machinery. So which outlines the principle for risk assessment and risk reduction to help the designer for achieving safety in design of the machinery. So could you please click on the this link, program of work MBD40. Okay, never mind. So this is the just a list of the standards which has been published. 32 standards. These are also available in our website. Next slide, please. In ISO TC, in ISO 12100, the classification of the safety standard is there, which classifies as type A, type B, and type C. Our earlier experts also mentioned that, but I will read the text which has been mentioned in ISO 12100. So type A standards are the basic safety standards, giving the basic concepts, principles for design, and general aspect that can be applied to machinery. So it is like a foundation of a building, like rightly said by Mr. Samir, that any machine risk assessment of as per type A standard is applicable. So, and it is the right of any employee to work in a company and to have a safe working environment. So he should be happy person to go safe every evening to his home without having some injury or any severe injury. So type A standard are there. Type B are generic safety standard, which are dealing with one safety aspect or one type of the safeguard that can be used across a wide range of machinery. And these are further classified as per 12100. Type B1 covers safe standard on particular safety aspect, be it safety distance, surface temperature, or noise. We are also having type B2 standards. Next slide, please. Type B2 standards are also on safeguards. For example, two hand control device, interlocking device, pressure sensitive device guards. So these type B standards are applicable to a machinery or a group of machinery. And type C standard as per this standard are machinery safety standards, which are dealing with the detailed safety requirements of a particular machine or a group of machine. So BIS is actively working on type C standards. Recently we have published plastic molding machine safety standard, which is type C standard. In PGD department, we are also having type C standards on manufacturing machinery as well. Details are available on our BIS website. Next slide, please. So the primary and ISO 12100 has been adopted in dual numbering as IS 16819 2018. So it provides the designer with the overall framework and guidance for decision during the development of the machinery to enable them to design machines that are safe for their intended use. It also provides a strategy for standards developers and will assist in preparation of the consistent and appropriate type B and type C standards. And one more thing I would like to mention here, that whether in the case where the provision of type C and type A differs, then type C standard take precedence. That means then type C, the requirements of the type C standard has to be complied. This has been mentioned in the introduction of ISO 12100. The concept of the machine safety of the machinery considers the ability of a machine to perform its intended function during its life where risk has been adequately reduced. We can reduce the risk, but it is at the cost of that means we have to invest more to make it make the machine more safer. But generally the designer, they do the designing part to comply with the regulations which are applicable to them and to meet the requirements of their customer. So they take assistance from these type A, type B and type C standards for designing their products.
Mr. Gupta, could you be a little faster? We are actually run out of time, sir. Please.
Yeah, please. Next slide, please. Next slide. So these are the various hazards that can lead to any injury or fatality. I will not mention here. Next slide, please. And hazard may happen in all phases of the life. This has also been discussed. Next slide, please. So the basic purpose of the safety standards are for safeguarding people, as safety is the basic need. Everybody wants to work in a safe environment, and safety is a management task. But involvement of the other stakeholder like operator of the machine, the maintenance guy, or any other related person, they are also involved and equally responsible for safe working of the machine. And of course, expert knowledge is required for installation and for designing the machine. So these are the various relevant clauses of ISO 12100, where risk estimation, risk analysis, risk evaluation, risk assessment, and risk reduction has been defined. Next slide. These are the strategies which has already been discussed by earlier experts. So these alternative methods are used to reduce the risk and to make the machine more safer. Next slide, please. Next slide. So these are the various risk reduction strategy at machine design, machine engineering control, and administrative measures. These are in front of you, and right. So this is from my side. Any question? I can take those questions.
Thank you, Mr. Gupta. We'll take the questions after the presentations. Now I would request Mr. Samir Kanchan to come in, and he's a machinery safety consultant, has around 24 years of experience, of which the last 13 years is with the machinery safety consulting and function activity. He's also a certified functional safety engineer by TUV. So he's from the academic background. He's the bachelor's of electrical engineering from Kurukshetra University. So I welcome you for your short presentation, please.
Yeah. So good afternoon to everyone. And I hope till now you have taken a note of all the expert advices regarding risk assessment and making a machine safe. So I will be taking very few slides. I have effectively, I think, 4 slides, and I will be talking about why risk assessment should be done. Okay, my slides, please, Manoj. Yeah, next slide. So this is what we do in the market. We do training, risk assessment. Next. Yeah, we give safety solutions. We do validation, and we also support for CE marking. Next slide. Yeah, apart from that, we also offer further services which are listed here, which are more related to, you can say, assessment only, but part of assessments, different types of assessments. Okay, next slide, please. So I just wanted to relate risk assessment with doctor's approach to human safety when you have a cold or cough kind of a symptom. So next. So there are 2 cases. In case A, you have say fever, cold, and cough. You don't consult a doctor, and you take medicines from the neighborhood shop, and either you are cured or your cure is delayed. Okay, and the chances of relapse of that ailment is very high because you have not gone to the core of the ailment. And now there can be case B. Next. Where you have the same fever, cold, and cough, but you have consulted a doctor. Probably you have also done a test, and you have taken a medicine based on a prescription from the doctor, which will ensure that you are cured faster, and there is a little chance of relapse of the same ailment. So now coming to the machinery part, why risk assessment is necessary? Next slide, please. So let's take a blister pack machine. This machine, this we did safety implementation long back, and actually we didn't do the risk assessment. But we provided all the safety guards as per ISO 14120, and also we provided all the interlocks and emergency stop push buttons as per relevant standards. But we didn't do a risk assessment. Next. What happened after a month? We saw that interlocks were bypassed. You know why? Next. We found after a month when we visited this site and we found that interlocks are bypassed, we tried to inquire why it was bypassed. And we came to know that for printing on the blister packaging, ink had to be poured in a tray in the running machine for better applicability of the ink. Plus, the blister packing material had to be aligned for every new job between the rollers in running machine. And because of this, we had not given any provision for this. And that's why they bypassed the interlocks and they did all these functions with the running machine with no interlocks. Next slide, please. Take another example from a food machine user. Here, I hope everyone will know that there is a Duff dividing machine in a food industry which makes bread or any such type of industry. So one person was cleaning the blades. It was a cleaning activity which was being carried out. And the second person was operating the blades, because you cannot clean all the blades from one position. You have to rotate it one by one and clean one by one. Okay, so the second person was rotating it whenever the first person was saying rotate. But what happened, eventually there was a miscommunication between the two, and the first person lost 3 fingers of his right hand while cleaning because he rotated when his hand was inside. And we found out that there was no risk assessment done for this cleaning mode, and the basic reason was that this first person who lost his 3 fingers, there was no exclusive control with him so that he could stop or he could run or stop. Next slide. A similar kind of incident happened during a press machine operation. The operator loads the job and tightens the base to the jigs or fixture, and he starts the press with 2-hand push buttons, and he is standing outside. And as you can see, there are safety light curtains also mounted on the machine. But what happens, he suddenly sees that he has left one of the tool, the tightening tool on the inside the press machine itself. And then he immediately puts his hand inside to remove that tool. But by that time, the press has already started moving. And because of that, he has a major bone fracture of his hand. And you know why this was done? This was also taken up by Mr. Samir Desai during his presentation, that this light curtain, safety light curtain, was not mounted at the right distance. Okay, so this is also a very, very important aspect of risk assessment. Next slide, please. So with the 3 scenarios, we always see that we have to get into the core of the injury chances or the sources of injury. And it is not only the normal operative mode or the auto mode where the risk assessment should be done, but we should also do it during other modes of operation And as others have said, it should also be done during other, life cycle phases of the machine, right? So this is all about my presentation. We can take up the questions now. Okay. Thanks a lot for my presentation. Next slide, please.
Thank you, sir.
Yeah. Okay. So I will request all the panelists to switch on their video so that we can take up the questions which are put by the attendees. Yes. So I will take very few questions because we have very limited time. And my first question goes to Mr. Wagner, Mr. Herman Wagner. And the question is, in the reference to the CE mark, whether assessment, safety risk assessment can be done only for the completed machine or also for the partly completed machine. So, Mr. Herman Wagner, this is a question for you.
No, risk assessment can always be done for a machine. It doesn't make sense, or the machinery directive doesn't make a difference between a completely completed machine or a partly completed machine. You can always perform a risk assessment for, let me say, parts of a machine, like components that can be put together to one bigger machine.
Okay. So what you're trying to say is that.
But so sorry. There is a difference. You can declare for a complete machine, for a complete and a completed machine, that it is in conformity with CE requirements. But for a partly completed machine, you can't do this. There you have to create a special paper that says that this partly completed machine that must be incorporated into a completely completed machine.
Okay. Okay. So what you are trying to say is there's no difference between a partly completed machine and a completed machine, completely completed machine, and the risk assessment should be done on both the machines initially, and then finally we have to do on the completed machine.
In the aspect of a risk assessment, it doesn't really make a difference between a completed machine and a partly completed machine. For a partly completed machine, you only have to keep in mind that may be some more residual risks that you cannot cover with the design, because you have some functions not, for example, the walling or something like this. And
okay.
But this says final safety requirements, they must be told the final manufacturer of the machine.
Yeah.
That there will be some residual risk.
Okay. Okay. Thank you, Mr. Aman. Yeah. Next question is for Ms. Maitri Sawant, and it is asked by Mr. Suhas. He is asking, does the safety PLC compatible with any safety product brand, or it is open for any product to be used? I mean, any safety PLC available can be used with any other product, or it is to be used only with that particular brand where the PLC comes from? Can you unmute your mic? Yes.
I'm so sorry. So I would say that it is in a total system, there might be products of the same brand, or there might be products of different brands together. So that doesn't mean that you have to have products of same brand in the system. So there are possibilities of interoperability also. It is depending on, so when your safety PLC is talking to other devices, it depends on what platforms they are talking. So maybe hardwired platform or any protocol that they are talking on. Like I mentioned about ProfiSafe as one of the protocols. So any devices, irrespective of the manufacturing, irrespective of the vendor, if they are supporting ProfiSafe, then the safety PLC also supports that device.
Yeah. Okay. So what you are trying to say is that if it is hardwired, there should not be any problem. But if it is on a protocol, then definitely we have to see what protocol the other device
Yes.
supports. Right?
Yes.
Okay. Thank you. Thank you. So my next question is there for, I think, Ms. Farah. Can you give some insight on market surveillance, how it is done in Europe? Yeah. What is the methodology in brief about market surveillance?
Thank you. So according to the European system, before a product becomes available on the EU single market, there is no market surveillance control. So overall, as I also tried to show in my slide in the presentation, a lot of responsibilities are given to manufacturers in the European system. So they are responsible for doing a risk assessment, complying to the right conformity assessment procedures, affixing CE marking and drawing up technical documentation. But then market surveillance really serves as a sort of public control element to balance out in the European system.
Okay, yeah, thanks a lot. Thanks a lot for the overview on market surveillance in Europe. Okay, the next question is for Mr. Chandan Gupta. Actually, we want to know, we have adopted 32 standards, as you said in your presentation, from under MED 40. So do we have any plans to adopt further safety standards, especially the Type C standards? Kindly unmute your mic.
Sorry, as in my presentation, I mentioned that we are in process of identifying Type C standards. We are already having standards for plastic molding machinery. We are having standards on manufacturing machinery safety.
The voice is lost. I think the voice is lost. Okay, can anyone hear, everyone hear me?
Yes, sir.
Yes, we can
Yeah,
hear you.
okay. So I think
Yes.
Chandan's voice got lost. So no problem. We will take up the next question. And this question maybe, yeah, this is for Mr. Samir Desai. And this question is asked as, is it possible to detect human parts when inside a machine? This is asked by Mr. Venkataramana. Is it possible to detect a human part, okay, when inside a machine?
Now, this is the typical questions which is coming from the subcontinent, because
Yes.
people would like to avoid, I would say, treating. Yeah. So this is the question people ask: can we identify or can we differentiate between human and other equipments? So I assume that this question has been asked with the reference that if in my machine, if I put some equipment, some metal part, some wooden part, or if the human is there, then there has to be a different safety mechanism. So this, I would say it's not, right now it's not possible. But what we can do, we can study the applications. For example, we have implemented certain safety solutions where we have use that if the forklift is coming for the palletizing machines, we can identify that there's a forklift and we can, bypass the safety. I mean, not bypass, actually, we can mute the safety requirement. And if somebody is walking there, yeah, so we can detect that that person is walking there, there is no forklift, and at that time the safety is not muted. So answer, I would say mostly answer to this question comes to no, but
No.
there are
Okay.
certain applications where we can identify not human, but something which is not human, that can be identified and actions can be taken. Yeah.
Yeah, I understand. So actually, yeah, this question could be put in two ways. The first one is whether only a human body is to be detected and the other objects are not to be detected. And the second is everything can be detected. So as you rightly said, everything can be detected, whether it is human body or any other object. Okay, so everything will be detected, right? So what I will do, since we are running short of time, we will not take further questions, but I have a question for all the panel present today. And other question, Manohar, can we take other questions later on through email or something, so that I will
Yeah,
not
we
take
will
them
do
right
that.
now?
Yeah, we'll do that.
Yeah.
We can
So-
do that
so-
question. We can.
Yeah, so what we will do is we will take one very important aspect of functional safety assessment. And what I wanted to put a question across to all the panel is, will implementing safety on a machine increase the cost of the machine, especially when we talk in respect with respect to India? So what is your view, Mr. Samir Desai, on this?
I think he has delinked.
Yes, delinked. Okay, so can we ask Ms. Matre, what is your view whether implementing safety on a machine will increase the cost of the machine in India, especially from Indian
Yes.
perspective?
So as per my view goes, I think yes, it definitely would increase the cost, because if we check about implementing safety and the 3 stages that we have to change the design, we have to change the technical way in which we are going to program the machine. We see that as I spoke about the automation solutions, even the automation solution has a different PLC with a higher capabilities for doing the safety operations. So all in all, if we look as a whole solution, and even further to that, the testing and validation goes, we are giving a machine with a safety as a value added feature, we can say. So that makes it important, and that makes it a vital machine. So I think the cost would definitely go high.
Okay, Mr. Herman Wagner, what is your idea about it? Because you are from Europe and you have been implementing safety on machines since ages. So has it increased the cost of your machine? Yeah.
I think it's not the right question. I think the question is more what would be the cheaper or the more expensive objective. Of course, safety parts make a machine more expensive, but if you don't implement them, you leave them out, you transfer the probably the costs to other shoulders.
Yeah.
To the people, you socialize these costs.
Yeah. So what you are trying to say is, yes, initially the cost will increase, but if you see the whole machine in a holistic manner, means the machine is built and given to the user, and user is using it in a safe manner, then probably the cost will be justified, because there will be no hazards or accidents on the machines. Mm-hmm. There will be no outages on the machines, and there will be no you can say production losses on the machine because of any accidents happening.
Yes.
So overall, yes, yeah.
We should not only.
So this is what. Yeah.
Spot the costs of purchasing, but let me say the total cost of ownership. If you have one accident at a machine, you have a stop in the production, and these costs can be avoided, and other
Yes.
costs also for recreation
Yes.
of the injured or hurt person.
Yeah, this will also, improve the image of the company where the machine is being operated, because there will be no accidents. Any other view, Mr. Chandan Gupta, on this?
Maybe Samir, I can add something here. People are asking this question because
Yeah,
right
just a minute.
now
I think Chandan is just speaking. Chandan, can
Yeah,
you
sorry.
unmute your mic? Your voice is lost, Chandan. Sorry, Samir Desai sahab, can you please elaborate on this?
I think all the panelist answers are still valid, but I would like to add one more dimension to it, that right now the implementation of safety is not mandatory. Let's say tomorrow it becomes mandatory, then the cost part will become redundant. So because if this is mandatorily you have to implement, you are enforced, so everybody has to do this. So right now people are looking at the cost because some people are doing it, some people are not doing it 100%. So maybe this is the one part, and second part is, as Mr. Wagner mentioned, total cost of ownership. Yeah, you have to look at what will happen if there is an accident, if there is somebody is losing limbs or life, or what about your image. And so these are the two aspects I would say. After implementation of this mandatorily standards, 5 years down the line, people will not ask these questions. I'm pretty much sure about this.
Okay. So in the long term, I think this will become irrelevant.
Yeah.
Okay, this is what you're trying to say. Okay, but I think initially this is a problem, or this is a interception that this cost will go increase, and then people are have apprehensions whether to go for it or not. Okay, right. Thanks a lot for all your comments on this. And Vijay, can we wind it up?
Yeah. So it has almost crossed 2 hours. So I
Yes.
thank all the panelists here, starting from Mr. Samir Kanchan, who was an excellent moderating the entire session. Thank you, Ms. Moyer, from Germany, that you made some time out and presented on behalf of Alok. Thank you, Madam Maitri, for giving your valuable inputs. Obviously, Mr. Wagner, I'm sorry, I thought I've committed that I will be the entire session will be over by 90 minutes. I don't know whether it has just jeopardized your next schedule. I'm sorry for that. Thank you, Ajmal. Thank you, Mr. Chandan Gupta. In fact, we'll be sending the presentation after getting the consent from the other presenters to all who have who have logged into this session. And thank you, Mrs. Samir, also, sir, from SEC, for your valuable inputs and a very excellent presentation. And thank you all. Wish you all safe, and hopefully things are slowly coming back to normal. And by the month of the next 2 months, we hopefully will see the earlier mode of life, which was there last year. Thank you all.
Thanks.
Thank you very much.
Thank you.
Thank you.
Thank you, everyone, for your patient listening. Yeah, thanks.
Thank you.